and we were a fabless semicon company, and we were actually producing I/O connectivity chips for global market in the initial 7 to 8 years. And over the last few years, we've been providing silicon engineering and product engineering services to customers globally. And in fact, I mean, we were involved in more than 600 tape outs over the last 26 years. And we worked on designs that actually went into, that were done in 180 nanometer all the way down to 2 nanometer. And as part of silicon engineering services, we've been working on turnkey ASICs, where we take the responsibility of, maybe customer actually gives us a specification or a design, and we hand over silicon back to the customer. And because we have product engineering services also, we basically support our customers on the embedded software, system design, and so on and so forth. And one more important aspect that I wanted to talk about is the learning and development center that we've been actually promoting. And over the last 15 years or so, we were able to train more than 3,000 semiconductor professionals, which are actually part of either MosChip or companies in India and abroad. And again, as part of turnkey ASICs, we've been delivering silicon to customers. There are, two projects that I wanted to bring to your notice. There is a GDB ASIC, GNSS, a digital baseband ASIC that we did for SAC very recently. This was done in 28 nanometer technology, TSMC 28 nanometer HPC plus. Jairam, you can probably show it to Ashwini ji. So this silicon was actually delivered to SAC, and this is first pass silicon success, and it is fully functional. And to just to give you an idea about this design, it has about 500 million transistors.
500
million transistors.
In this small, this is the size of a nail. 500 million is 50 crore?
Yeah, yes sir. Yeah.
50 crore devices inside.
This is the power of semiconductors. This is a small chip designed by our team here, MosChip team. This is the size of a thumbnail, and it has 50 crore devices inside it. 50 crore devices. Right? Great work.
Yeah. Thank you, sir. And this basically goes into navigation receiver systems. And apart from SAC, we are very, very honored to have gotten an opportunity to work on our indigenous high performance computing processor, SOC, which is OM processor that we are doing for CDAC. And we will probably get an opportunity to discuss about this project maybe at a later point in time. So these are two projects of national importance that I wanted to talk about as we are meeting here. And coming to the smart energy meter IC, and we call it Vision, that we are doing under DLI scheme. Again, as I said, MosChip was a product company, and even though we've been doing design services, we wanted to do a product, and we wanted to be part of a product building nation, and we have taken up building smart energy meter IC, and some of our colleagues were actually talking about the difficulty in building analog IP, right? Smart energy meter IC has 6 important analog IPs, and hence, what we wanted to do was, we wanted to do test chips, right, for analog IPs, and we did tape out 2 test chips in TSMC 180 nanometer, and VTC1 had 4 IPs, and VTC2, the test chip 2 has about 2 IPs. And the VTC1 IP validation, I mean, we actually completed, and we are doing characterization at this point in time. And VTC2 has actually arrived just now, and we are going to validate the ADCs that we actually built. And on the digital portion of the chip is being validated on the FPGA platform, and with the entire software and the DLMS stack. And we are planning to take this out in May this year. And also to make it completely indigenous, I mean, we have developed both the digital IP and analog IP in-house, and the processor core that we are actually using on Vijay is from Incore. In fact, our team is working with Neil and others from Incore. So that way, the chip is entirely, the IP is entirely designed, I mean, indigenously. But the initial chips we are planning to get them done by TSMC. But because this is 180 nanometer, we are also running a parallel thread where we would like to actually get Vijay done in SCL. In fact, VTC1 and VTC2, those 2 chips, even though they were fabricated in TSMC 180 nanometer, we got the packaging done by SCL. Jairam, can you show them to Ashwini?
Smart energy. Meter energy.
Yeah. So, yeah, the plan is to basically design this chip indigenously and hopefully get it manufactured by SCL in 180 nanometer and take it into production. And once again, I mean, thank you so much for the opportunity, and I'm very, very honored to be here and presenting what we are actually doing in front of you. Thank you so much.
How was your experience of taping out at SCL Mohali?
The interaction, the engineering interaction and the PDK support and all that was pretty good, sir. And the turnaround time is basically longer than what we have actually experienced at TSMC. And we also know they were basically limited by capacity, and they also ran into etching machine issues and so on and so forth. In fact, VTC1, the first chip that we did for TSMC, the same chip to validate 4 IPs, we taped out to SCL. And as we speak, those chips are being shipped to MosChip. Yeah, right.
There is a very important point made here. If you design the chips and after that how do you tape them out, one of the factors that we considered was MPW, as I explained. Now, as we go forward, as the semiconductor ecosystem is building up in our country, and as we become a product nation, as MosChip has been providing system services, but now MosChip is becoming a product company, right?
Right. Yeah.
From services company, you are also becoming a product company. Now, to be there, we need tape out facilities within the country where preference is given to startups in a big way. So that's why we are taking 2 steps. Apart from the MPW which is there, in addition to that, we are taking 2 more steps. First step is we are upgrading SCL Mohali in a big way by investing about 4,500 crore rupees in it. 4,500 crore rupees we will be investing in SCL Mohali, and SCL Mohali will become the, in a sense, lab for entire semiconductor ecosystem in the country. So any startup who wants to design and validate the chip, tape it out, they'll have this facility available to them as a government facility so that our startups get a very good tape out physical production facility in the country. Also for the students. So this will be at a node which is a very well used node but a legacy node. The second facility which will be used for taping out, that will be Tata's Dholera fab. So the Dholera fab, 28 nanometer to 90 nanometer and SCL 180 nanometer. So in a sense, close to 80% of the chips which are manufactured in the world, or maybe 75%, 75 to 80% of the chips which are manufactured in the world, that entire ecosystem we will be able to build in our country within next 2 to 3 years. And the path beyond that is also very clearly visible, which I'll share with you in the closing remarks.
Right. Thank you, sir.
Thank you, sir. Before I invite Vinayak Dalmia from Third Eye Tech and DV2JS for the next presentation, I have a small request to make to all the presenters. Kindly be precise and short. We are already behind schedule and there are still many applicants to present. So Third Eye Tech or DV2JS as they are known is working on development of another key critical component in the surveillance market, which is the image sensors. Use this or you can use this, right? Or you use this.
Good afternoon, everyone, and thank you to the Honorable Minister, to DLI, and to the entire leadership at MIT for making this possible. I think, Sir Minister, sir, you spoke about the value of the tools. So I have, in our company now, we have almost 100 designers and a global presence. When I talk to my American teams, they are amazed that the tools are provided by the government. Because in their country, that is unheard of. And if we didn't get those tools, the cost per year just skyrockets. So that is, thank you so much for that support, sir. So you made a comment at Davos on two things which really stuck out. One was on sovereign AI. And I think within sovereign AI, physical AI becomes the next wave. And you also spoke about analog. So when we talk about the physical to digital interface, analog sensors become essential. Whether we talk about drones, we talk about surveillance cameras or other kind of applications. So we are focused on sensors. As I said, we have a global team. We are very proud to say, sir, that normally it is American companies setting up offices in India. We are a young company, but we have set up operations in NCR, in Bangalore, and all across the US, and scaling over 100 designers already. We're also very proud to say, sir, thanks to DLI, some of the C-level leadership, technical leadership from one of the largest global semiconductor companies have joined us. onsemi, OmniVision, Global Foundry, Analog Devices, and defense companies like Raytheon and BAE Systems. Proud to announce, sir, that the CTO of OmniVision, which is one of the world's largest sensor companies and the largest fabless company out of China, their CTO quit their company in May 25 and has joined us as CTO. So that's just sort of an update, sir. We are working, the product we're working under DLI, sir, is a image sensor. So that's the heart and soul of a camera. For surveillance market, we interviewed more than 20 Indian surveillance camera companies, and we realized that more than 70% of them are buying chips from a single Chinese source. And we also zeroed in on all the specifications. So what we're doing is we're doing a mass production now with customers, and they have 6 modes in the image sensor in the single chip, sir, from very low light to very high speed. A single chip will be able to do that. We have contracts and customers, sir, with Bharat Electronics, We have contracts with Kane Semi, which was announced and signed in Semicon, and these are all for mass production. We also saw in 2024, you will be happy to learn that this sort of wafer, we had done a mask tape out at TSMC. And per TSMC, this was the first time that they had declared an Indian fabless company as an innovation partner. And I was personally invited to TSMC to speak and give an address. And now we're doing a mass production, not with TSMC, but with another fab in April, which is going to be for volume production. Our hope, we're in touch with Tata and TSMC. Our hope also is obviously that we bring that fabrication to India as and when that is ready. So I just wanted to give you some context, sir. There are about 10 billion image sensors produced every year, and that number is scaled.
To EDA tools and a whole set of IP cores, and we made CDAC as the sovereign repository of EDA and IP cores, and using that mechanism we provided this big facility and a big enabler to the startup community, and that gave them one major leap into the design world. Because now you have the EDA tools, you have the IP core, then you can use your team's brains and you can work on a concept and then apply for DLI. Funding becomes automatic once you have developed a concept. Otherwise, it becomes just a PowerPoint slide if you don't have the EDA and IP. So I thought that's, thank you Arjun for bringing it up.
Of course. Thank you, sir. So, we have had a bunch of achievements. We have launched a complete range. Prime Minister in 2022 said that he wants India to become a chip maker from a chip taker. And that statement really resonated with all of us. So I think the preferential market access would be a really big game changer for chip companies. Especially if you look at Bioministry, then look at sort of the concept of BNE or bio-nominated equipment. So the second is, as I am as a company getting into mass production, I'm learning this, is the wafer pricing with fabs. So let's say my friends in China get a wafer price of, let's say, $1,000 a wafer. I get a $1,500, $1,600 a wafer. And the whole competitiveness and the unit economics is determined by the wafer price. If that's something that can be done, that would be a game changer. Thank you very much, sir. Jai Hind.
Good afternoon, sir. My name is Rakesh Adhikari. I am from Incise Infotech Private Limited. Incise was founded in 2010, and from 2010 to 2024, we were mainly doing services. And in 2024, we applied for DLI, and we got this opportunity. And now we are proud to say that we are designing the India's first LED driver chip. Right. So our first product is linear LED driver. So it is basically 9-watt bulb which we are designing. We have already taped out this chip. See, this is a high volume and low margin product, and it is basically 100% imported currently from China, and all from Chinese companies. And our competitor in China, they are designing it, they have a 1 mm square chip, right? So our target when we started this project was to make it less than 1 mm square chip, right? So I'm very proud to announce you today that we could make it 0.98 mm square with 2 registers, saving 2 registers, onboard registers, and putting those registers on inside the chip. Right. So so this is our first chip, and we want to be in our roadmap. We want to be so currently we are designing the 9-watt bulb. right? Later on, we want to do chip for tube lights, then chip for street lights, then chip for automotive segment as well. So we want to be in this LED segment. Yeah.
Our products be mass produced in SCL Mohali?
Yes, sir, but they don't have this 500 nanometer technology. Actually, so far, so this product requires ultra high voltage UHV process, right? Which basically is directly taking the 220 volt and converting it to low voltage, right? So it's not that but yes, if it can be upgraded, this can be really game changer. So this is the picture of real picture of my layout, which we have taped out to foundry. It is 0.98 mm square, and we will be getting the samples on 15th of Feb next month. So it has huge market size. 2 billion plus chips are imported every year from our neighbor country. So the support which we need from government is to make it basically we have achieved the target area. Now for selling we would be requiring the support. Thank you very much, sir.
So, good afternoon, everyone, and especially thanks to Ashwini Vaishnaw ji for giving us more time on the desk. That is the number one thing. And Amitesh Kumar ji sir as well, and all the other people from CDAC and my team who've made this possible. So, I am Shashank Kumar. I am the CEO and co-founder of Multi Nanosense Technologies. So this is like a slight different flavor to this room. So we are also a sensors primary company, wherein we are working on MEMS based sensors as well as other technology sensors for gases, wherein we are looking at different kinds of toxic gases, explosive gases, combustible gases. We've got a industry horizontal use case across multiple sectors. Just a brief background about us. We have already commercialized our solid state electrochemical hydrogen sensors. We are even exporting to about 45 customers in Australia, US and Europe. And our journey with the semiconductors started off actually with IIT Bombay, wherein we were supported by the INUP program. We made our MEMS chips there. We proved them out. We wanted to go into a production level. International foundries were proving to be a real problem. So then we went to SCL. And we went to SCL. SCL actually helped us out. We successfully taped out our MEMS chip at SCL. And today, like that chip, we've converted it into a product along with onboard electronics. And we have sold those sensors for a hydrogen ICE engine truck to Tata Motors. This sale happened just in the last month in December. And now we are a DLI applicant. We got the approval in about August of 2025. So we are now building next gen of these MEMS gas sensors as one chip, and we have a dedicated AFE SoC which we will combine with this. And we will be targeting multiple applications. We are going up against the biggies of the world who are in the Honeywells and ABBs and all these kinds of people in the world. They are our competition, and we have the ambition to beat them. And extremely high performance, extremely better sensors in terms of the size, the functionality, the kind of use cases that we can go around. We recently raised a 25 crore round from Mr. Ashish Kacholia, and this is what is coupling along with the DLI that we have, so we are able to leverage both these sources. And we got several POCs lined up with the biggest names in the country: oil and gas, power generation, transmission and distribution. So several use cases for hydrogen safety, methane safety, pipe natural gas safety, predicting thermal runaways in lithium-ion batteries. So wherever new energy, wherever new sources of energy storage, energy generation, energy transportation are involved, there are issues of safety, process optimization, asset health monitoring, tracking them, smart grids where you want to ensure whether transformers are good or bad or whether they are going for a toss. So those are the kinds of things we can do with our sensors, and coupled with the AFE SOC, it becomes a really, really powerful device, really miniaturized. We are able to beat people on cost, beat them on performance, as well as beat them in terms of the overall deployment possibility. So that's just a short thing about us. A few help that we would actually require here is, once we have these products out there, like volume is the biggest thing and government is the biggest consumer. So we would request if there can be some sort of engagement where we can get a POC, then merit decides what happens. But we get POCs with these government departments, which can probably be promoted by the DLI group. That would be really helpful for us to make these products actually speak in the market, and then we compete on a toe-to-toe basis with whoever is there. And like today in India, at least, we are the only company who make these sensors in the country. Rest everyone is just importing. They are all imported sensors. Nothing is made in the country today, except what we are doing. So thank you. Thanks for the time.
Good afternoon, sir. We are Green PMU Semi, a fabless semiconductor company with focus on building analog and mixed signal IC solutions. We have had an experience of working on legacy nodes of 180 nanometers, and we have done some IPs for some customers in advanced nodes of 4 nanometers also. Through DLI, we are building an indigenous energy harvesting IC solution. You know, today, there are a lot of IoT devices, low power IoT sensor devices, which are limited by battery. Now, we want to extend the battery lifetime by using energy harvesting technology. There are two ways. Either you extend the battery lifetime of the system, or you can make the system autonomous in itself. The primary source of energy around us, you see the illumination in this room, which is solar, temperature difference in industries, or the vibration across the industrial machines to proactively monitor them, or the RF waves around us. So we want to capture this energy and translate that into a usable voltage, which could extend the battery life of the system. So through DLI, we have done a dual source, dual input energy harvesting IC. We do have a single input energy harvesting IC in the market, but the first dual input DC source energy harvesting IC through the 4 tape outs we have done, and we validated the chip. The next step is to take this chip to the customers, get it validated in the system first, and take it to the engineering volume. So roadmap ahead is, along with this, for the dual input sources, we want to validate this for the AC input sources, which are vibration as well as RF. We do have a chip demo if you want to really see that. The chip we have built, like I said, this is a solar panel, and it is only indoor illumination. You can actually see the voltage generated in the space. 1.6 of because it is shadow. But you can put so much. Like, if you just put a little bit of light, you go to light. Such a small energy you are here. So this is for the DC inputs, and maybe going forward we can live manipulation. Let the immediate team see. Sir, they are equipment. The team. So since like a lot of sensor companies, IoT companies, we want to see if we can also be and plug and play to be integrated so that we can have an advantage on top of whatever production we will get in. In any medical application, any industrial application, we want to bring in that. And yes, thanks a lot for the CDAC team. We are a pretty young company starting out from Hyderabad, and the support and handholding has been dominant for us, and we hope to take this forward to a leap. And like I said, market, sensor deployment, critical. This could be the critical to add on advantage where the battery is a bottleneck, and we want to extend that battery and make it autonomous. Thank you so much. Good afternoon, Honorable Minister and everyone. So I am CEO and founder of Sofoscience Technology. And before dwelling into what we are building, I would like to thank for two things which people don't talk about is we have spoken about the DLI tool support, and just give you background mine. I was in Europe and building chip for early cancer diagnostic, and there also there is a thing called Euro practice. But the uniqueness about the India DLI EDA tool is that you can commercialize your chip, but in Europe you cannot do that. For that you have to pay a lot of money. So that is what an EDA tool is really backbone for every semiconductor company. So that is why I would like to thank this is a great opportunity given by the a young company like us. We just recently started 6 months to 8 months back, and we are able to build the chip, and we are going to tape out in April this year. And apart from that, DLI give the credibility, even though we don't have the chip right now, and we had the just idea, and because of the credibility, we got $2 million funding from Blue Hill VC also. So these kind of stuff will give you, power you, not only with the tool only, with the manpower also, where you can build a very unique technology which can empower India and also for the globe also. So I'll just walk you through what we are doing is, so at Sofoscience what we are building is first of its kind in India. We are building a biomedical chip where all the world is moving towards edge AI and everything. We are working behind in backdoor, and we are giving them a data where they can do the AI, and that is very important, because if you have a very good AI processor, if you don't have good data, you cannot do anything about that. And that is where Sofoscience Technology is building. First product is a biomedical wearable chip, which will be very ultra low power, less than 100 microwatt we are talking, which can empower any wearables, which will be used mainly for your diagnostic of your vitals and everything. And we have already potential customer in India, wearables, and also in UK. So the good thing is people are recognizing these kind of thing, even though we are just very early phase, but they are ready to do POC by end of this year. And we have already filed so many patents, and we are in the process of filing patents. So that is all about. And looking at the timeline, what we are building, and as my background comes from the chip which we have built in past, first of its kind for cancer detection, and that is where we will go after this. We'll build a lot of health application devices, which never happened in India. So thank you for supporting us. And one on lighter note, in Europe you cannot call or text anyone if you have a EDA tool problem, but here you can text to Dr. Abhay and he will get solved. Thank you.
Big round of applause for Siddharth.
Ravi, you're coming. Okay.
Good morning, good afternoon, everybody. Before I go, I'll quickly talk about, when we talk of MMRFIC, it's basically acronym for millimeter RF. So why we started in 2014, and through the minister and the departments, I would like to first thank the government of India for whatever we have achieved so far. Beyond MeitY, beyond the departments here, thanks to them, and beyond them, it's been a wonderful journey for us. And so why did we start this company? We started because we wanted to make millimeter RF an Indian capable product component, from all the way from component to products. And so far, since the beginning, from 2014 onwards, we have pretty much come to a scale where we started with founders from TI, and we headquartered in Bangalore with 70 plus employees. And since the time we started till now, as a deep tech company, we have developed many products which is purely built to spec. What we mean by built to spec is all making a design in India make it as a product and take it to the scale where it can be productized. And the market we are focused is primarily on the strategic market so far. So defense is our major focus at this point in time. Though we have communication as a background and connectivity as a background where we can do IPs, like Minister told right now, we are in a position where we can scale from going beyond defense to other areas as well. So far we have patented almost 10 concepts in millimeter wave systems, and since the inception we've always been focused on cash flow. We have worked on making products that can generate revenue and scale the development. And more importantly, we have been invested strategically by an Indian company, Sansera Engineering. It's an Indian public company, and they have been invested in us since 2023 to scale the products which I'll quickly cover. So what we have done, we have always been an IC company. We started doing ICs way back from 2014, and the first IC which we did in silicon germanium was a W band. It's in the frequency of 100 gigahertz. We can say that in India is one of the probably 3-4 countries across the world where IC of this magnitude in W band has been done. And today, when we visited the RDC yesterday, there were missiles and seekers shown as a display from that has been developed. And very soon we'll be happy to know that the seeker that we have done, the components for the seeker that we have done will be pretty much going into production and taking it, being part of a display in the coming years in the RDC. So I'll just, because it's not related to So what we did next is, beyond IC we need to also make products. Unless we make product and solution, there is no way we can scale the volume of the IC that we do. And that is what our focus has been from 2016 all the way till 2022, where we developed our own indigenous radar for the defense market. What you see in the corner is a surveillance radar which we developed, and it's being used by the PSU in the country for productizing it. So this has been our journey. So coming to DLI project, having done for the last 7 years or 8 years components for the market, with DLI coming in, we are probably one of the last entrants into the DLI scheme, thanks to all the committee members, CDAC, DLI, MITI, for giving us the opportunity. This product also is for defense and space. Both these are areas where components that we make, unless we are having indigenous solution and indigenous control of the components, scaling the products, scaling to volume will be always challenging because of restrictions, because of import restrictions that may come later on. So by doing this kind of products, and this is a beamformer chip that we have proposed and doing it in the carbine, and the focus is today both DRDO and ISRO are two companies or two entities who are looking at this product. So by indigenizing and making this chip in-house, this is going to enable us to take to production and have control on the Make in India program of the country. And we just started in August or September last year, and today we are looking at the first test chip tape out in silicon germanium in FY 27-28. And I, on behalf of my team, would like to thank all the opportunities that has come our way in the last 10 years of our journey in being able to enable what we can do at a small level to make Atmanirbhar a success in the country. Thank you.
Thank you. It's an exciting place to be here. Vaishnaw Networks, I'm a professor and I incubated it at IIT Hyderabad. This chip was actually incidentally was supported by MIT, and also when our beloved minister was a devotee as part of the 5G test bed. We've gone a long way. The silicon is here, the system is built, it is qualified. This chip is very similar to what we have in a cell phone, the communication device, but this one does pretty much the same job, but at very low speeds, and the battery lasts much longer, 5 years, 4 years of that kind. But it sends a little bit of data like voice or messages, sensor communication. So it is a system, and the applications are vast and very many. It connects not only to cell towers but also to satellites. There is a BSNL, Viasat, geostationary orbit beam coming up, and this device connects to geosynchronous orbits and sends data. So it is useful for maritime, fishermen, railways, asset tracking, defense, even soldiers, radios. So it is not one system, but it can be morphed into a number of very many applications. And the approach we took, slightly different from brilliant solutions presented today, processors, RFICs, sensors, many chips we have seen today. But the approach we took here is that a system, it has processor in it, it has GPS in it, in the silicon, and it has ADCs, DACs, communication analog components in it. So it's a fairly complex one. And it can be tailor-made for to address any narrowband communication for the next decades, to serve a vast segment. What is required to be done? The system is ready, tested, it's mass production ready, TSMC 40 nanometers. We intend to use the Indian OSATs provided we have volume orders. So what's missing today is some POs, not necessarily a grant, to take it to 100,000, 1 lakh, 10 million, 100 million. The scale up is required. So POs are required to be triggered, and possibly a preferential market access on different segments, whatever the segment is. I'll stop here. Thank you.
My good friend Kiran is one of the examples where and Professor Nandi, these are the examples where the academia and industry and the government, all the three major segments, have so well collaborated that it comes out with a solution. Thank you, Kiran.
So we have last presentation from Vervesemi. They were held up because of some traffic curbs. So they are here, both Rakesh and Pratap.
Good afternoon, everybody. So sorry we got held up a little bit in the traffic. I would be presenting about Vervesemi microelectronics and how we are connected with DLI and how DLI is supporting us and what are the status. So Vervesemi is a fabless company. We started in 2017. Before that, I had a lot of experience in semiconductors. In fact, one of the first person to start the semiconductor doing in India. 1991, I started semiconductors, so that was long back. We have around 140 IPs. We have around 25 products. We have 10 patents, 5 trade secrets. So we have some trade secrets which we have not applied. These are more related to machine learning. And we have a very smart piece of machine learning inside our chip that can take care of aging, that can take care of self-healing and so on, which is very essential for the space business, for automotive business and so on. So we are doing 2 projects under DLI. So one is the advanced motor control project. Here the application is the e-vehicle, the drones and so on. So it's a chip which we taped out in July 2025, and these samples are available now. So we are going to test this, so you can really see this part, which is the silicon part of it. So you can see a lot of analog and digital there. The second chip that we are doing is under the C2S project. This is the BLDC controller. So I have some announcement to make here. So we have to design 3 chips. So 1 chip we already taped out now. 2 chip we have already received the samples. So using those samples we made a motor. So you can see here we have a complete motor here, and we'll show you the video of this operation of this motor. After this I have this video also to show it to you. So it's like 3 chip solution, 2 chips are already done with India, and the 3rd chip we are going to do. And there are some special things which Pratap is going to share. So this chip is not only good for the BLDC motor, but also for the SR technology. That's what my friend was telling about this.
So for BLDC, the motor we built is also addressing one of the very unique problem which Indian manufacturers have. So all of our Indian manufacturers who are making ceiling fans or coolers or exhaust fans, they are all using induction, and their production plant is induction. Their labor force is trained for induction motors. So it is very difficult for them to migrate everything and then put a lot of capex on changing the plant completely. So what we did is we developed a motor where you just have to take the classical induction motor, just remove one ring with the magnet, the slip ring with the magnet, and the motor is transformed into BLDC, no change in winding, no change in anything. So all labor force which is trained for induction motor, we just have to train them to fix the slipping. And we have a video of this same motor, running with one of the customers' place. Let me see if I can connect to this laptop.
Not only targeting the market, but we have understood the market also. So that means the minimum side changes on our customer side to convert from BLDC to BLDC motors, and also this is valid also for the SR motor as well. So SR is basically a magnetless motor.
Very good. I think.
Thank you so much. Just show it also. पुराने वाले को लगाओ.
खुल जाएगा.
इसको छोड़ दो. Yeah. So let me show you another slide, the second slide, which is another announcement from our side. We have taped out a chip for space, which is ISRO. This chip is around 144 millimeter square chip. We received the samples, we packaged it. So this is our package chip, Indian chip. It has around it's around 20 plus IPs inside. This can take care of 100 ICs inside. So ISRO is using this chip, approximately 100 components, which will get replaced by one single chip here. And this is the board, and this chip is working. So that's a good news. Yeah, thank you so much. I have one point I think I just missed out, if you can, yeah. So on the support required from your side, so we have received good support from DLI, you know, in terms of time.
Right on this.
I already gave written there. Okay. Thank you so much.
Super.
It is my honor to invite Honorable Minister Ashwini ji for his comments and for his advice to the young entrepreneurs and startups.
First of all, thanks a lot, all the friends, for sharing the excellent work that you have done. And thank you, my friends from media, for being a part of this journey, because it was very important for you to see what work has been done by the startups and the established companies also. Some of them are have been in this journey for more than 2-3 decades. What started in 22 as a part of our semiconductor mission, our Prime Minister very clearly said that we must develop the entire ecosystem. And we must do a multi-year journey rather than just think of one scheme. We must look at the conversion of our country from not just a services country but also a product nation. These were the 3 broad visions that our Prime Minister gave us when we designed the entire program. And in such a short time frame, I am so happy that we have 24 startups as a part of the DLI program. Give a big round of applause to the DLI team. We had thought that we will be very lucky if we get 5 and we have 24. So that's a big thing, and so many of you have taped out, validated your products, many of you have found markets. The most important thing is that our thought process has got validated. Our thought process that we must provide EDA tools so that the biggest barrier is gone. Our thought process that we must give the IP so that the second biggest barrier is gone. And the thought process that we should provide the MPW, the wafer support, the tape out support. These 3 major part of our architecture, and as one friend from who has worked in Europe mentioned, this kind of support is not there in any country in the world. For semiconductor industry, for semiconductor startups, the support, the comprehensive support that India Semiconductor Mission has given is very unique. And we intend to double down on this, we intend to scale up this, and in the next version of our semiconductor mission, we plan to get at least 50 fabless companies going in our country. And out of these, we will get one AMD developing out of our country, one Qualcomm developing out of our country. That will be the journey in the next few years. And I'm sure we'll succeed in that journey. I have a few updates to give you. In Davos, when we had the semiconductor roundtable, practically every industrial leader expressed very huge satisfaction at the way our program has panned out in the last few years. And this is a huge change. I remember going to Davos in 22 for the first time when we said we'll be manufacturing semiconductors, we'll become a semiconductor country. People used to look at us and okay. 23 was a bit different. 24 when people started taking note of our program. 25 it was, oh, you guys have done something really significant. And this year, the entire industry leadership was saying, please tell us what you want. We know that India will become a major semiconductor nation. We don't want to miss out that boat now. That's the change which has happened in the few years. Now we want to focus on 6 major systems so that we develop our complete semiconductor design ecosystem in a very comprehensive way. These 6 major systems are compute system, compute logic, high performance compute, whichever way you call it, microcontroller, basically the compute as a category. Second is RF as a category, wireless, you call it millimeter wave, call it K band, Q band, whichever band you call, RF as a category. Third, networking as a category. For multiple different and especially cyber secure networking, what are the innovations we can do? Networking as a major category. Power management as the fourth major category.